Hello everyone. In this video we will talk about alcohol. Well, we know what alcohol is, right? So that's what we drink when we go to bar. Well, it's one type of alcohol, which is one molecule of alcohol. We're gonna learn a lot of different type of alcohol. They are all called alcohol. So what is an alcohol? So alcohol has a functional group. So this is what make the characteristics of alcohol. So it has a functional group, uh, which is, we call it OH. So OH, so this group is named as hydroxyl. So this group is called as hydroxyl group. It's called hydro, which is H, oxy, hydroxyl group. So if your molecule has this hydroxyl group, we're gonna call that alcohol. It's a special class of compound, just like we had alkane. Alkane is all single bond. Alkene is, if it has one double bond, then it belongs to a special class, which is alkene. If it has triple bond, then it's alkyne. So same here, if it has a hydroxyl group, then we call that alcohol. So what is the simplest example? So let's say, before we start there, let me remind you. So what is the water molecule looks like? So water molecules is this: you have one oxygen and two hydrogens, right? So it's like your Legos, right? So oxygen is always gonna have two bonds. So what if I replace this hydrogens and attach a carbon right there, just like Legos? And we know how many bonds carbon can have? Three. So let's add hydrogens, hydrogens, and hydrogen. And so that is the simplest alcohol that you can make. So in a condensed form, how can we write this? We can write this CH3OH. So that's called methanol. So that's called methanol. So this methanol is obviously very toxic. Uh, it's poisonous to our body. But let's talk about the fun alcohol, the most fun alcohol, right? So which is next one. We're gonna start like this: condensed structures. Oh, I'm gonna just write like this: OH, because oxygen can have only two bonds. So C, carbon can have four. Let's add another carbon on the left, and this. So let's add hydrogen now. So that is, so what is the condensed structures? CH3, CH2, and OH. So this molecule is called ethanol. So this molecule is called ethanol. So this is the what we drink. So this is the molecule that present in all of our drinks. So this is, well, this is not toxic. Like, this methanol will kill you. This will not kill you, right? Well, if you drink it too much, it will. All right. So that's our ethanol. So just by looking at these, can you guys figure out how we are naming this? The naming system is pretty simple. Okay. So first thing I'm gonna do is, let's draw a random molecule here. CS3, CS2, CS2, OH. So OH will always get the higher priority. So far you have seen double bond was getting higher priority. Now OH will get higher priority even than the double bond. So rule number one, find the longest chain that contains the double bond. Whoa, what just happened? That contains the hydroxyl group, contains the OH group. So in this case, what is our longest chain? This is the longest chain. So our chain has how many carbon atom? 3 carbon atom. So if it is 3 carbon atom, the parent chain would be B. 3 carbon atom is prop and it is all single molecule, so we're gonna call it propane. Then when you write it out, so E at the end, so let's write color code. So E at the end is replaced by all. Okay, OL, not LOL, right? Okay, so OL. So what should be the name? I'm color coding so that you will see the difference. Prop. So this is prop is 4. Then AN is because all of them are single bond. If it would have been one double bond, then you would have add EN. And then the last thing is last E would be replaced to all. So the name is propanol. So this is propanol. Okay, the name is not complete because hydroxy group can be on this carbon atom, it could be on here, it could be here. So you have to assign number. So number the carbon chain in such a way that hydroxyl group will get the least number. All right. Okay, so let's number our carbon atom here. So let's say we go left to right first. 1, 2, 3. So in this case, the name is 3-propanol. What is the other options? We're gonna name right to left 1, 2, 3. So in this case, it's gonna be 1-propanol. So which one shall we pick? Obviously, this is what we're gonna be picking, and this is not the wrong answers, right? That's gonna be 3-propanol. So let's delete this. All right, so let's do another one, simple one. CH3, CH, CH2, CH3, OH. Okay, first rule. Okay, I think I should draw it out here. Let's delete these. So let's delete this and we can draw it out here. Okay, CH3, CH, CH2, CH3, OH. All right, so what is the name? So what is the longest chain? The longest chain that contains the alcohol is this. So how many carbon atoms we got? We got 4 carbon atoms. Okay, let's do different colors. Okay, we got 4 carbon atom. So if it is 4 carbon atom, what is the name? Name is butane, but. Then we're gonna replace the end of this E with ol. So it's gonna be butanol. And how we gonna number them? We're gonna number them. What is the best way? We could number them 1, 2, 3, 4. So that's gonna be 2-butanol, or the other way around is gonna be, if we go other way around, so it's gonna be 1, 2, 3. So it's gonna be 3-butanol. So obviously, which one would you pick? The one that has the smaller number. So this is the correct one, not this one. 2-butanol is the correct answers. Okay, let's do one last example with this, and which will be a little bit harder. Okay, let's do this. CH3. Okay, so what is the longest chain that contains, what is the longest chain that contains the hydroxy group? Well, the longest chain is gonna be 1, 2, 3, 4. So you got it, 1, 2, 3, 4. I could have drawn this way as well. This is the longest chain as well, but both of them are equal length, so it doesn't really matter which directions you go. So I'm just gonna give left to right, that's straightforward. Okay, so we got longest chain. So longest chain parent name should be butane. Then butane would be, last E would be replaced by ol, so it's gonna be butanol. Then your goal is to give the hydroxy group the least number, so hydroxy groups get the highest priority. So we got two substituent here, this and this, but the hydroxy group is belongs to the parent name, so this one would get high priority. So if you remember, 1, 2, 3, 4. So in this particular example, if I go left to right, this is the only way I would get the least number, because if I go right to left, my OH would be number 3, right? 1, 2, 3. So so that's why, if you let me rewrite, if I go right to left, it would be 1, 2, 3, 4. So my OH is falling on third one, so which is we don't want. So let's delete those. Okay, so it's gonna be 2 butanol, right? But there are still one substituent left, and this substituent has one carbon atom, so that is meth, and because a carbon chain, so it's yl, methyl. And where is the location of this methyl? The location is on the third carbon atom, so it's gonna be 3-methyl. So the name would be 3-methyl. This is our substituent, and the parent is 2-butanol. All right. Okay, so that's all about the alcohol nomenclatures. I'll just give you another hint. Just like some people in some book, in the advanced book, instead of writing 2-butanol, people also write butane 2-ol. I know it doesn't sound fun, but this is also a correct nomenclature conventions. So look here, the 2 is coming right before the ol. Um, so you could add the number either beginning or in between, right before ol. So here I could have named my name structure as 3-methyl butane 2-ol, but that's not easy to pronounce. So the old method is kind of pretty obvious, 2-butanol. So you follow this method, like write the number before the name. All right, so that's all I had to say here.